still the limit, horizontal asymptote, vertical asymptote, removal discontinuity. For number 2, remember there's a radical plus or minus something. That means I should think of something every single time. What's that thing I should think of to do? Yeah, that's right. I need to use the conjugate. So let's review how to use that. So to properly use the conjugate, what I do is I write exactly the same thing down, except for the very difference of, so almost exactly the same thing down, but I change the sign in between the radical and the number. And then I write the same thing over the same thing because that's 1. Now remember, your inclination is going to cross these off, but we shouldn't because that's literally what we just wrote. Instead, we need to remember that this represents the pattern of difference of squares. And since it represents the pattern of different squares, we can use that idea. Remember, that idea is if I had something like this, x minus 3, x plus 3, what am I always doing? I'm squaring the x, writing a minus, and squaring the other number. So we're going to use that same pattern to evaluate the top stuff. I'm going to write this thing squared, so square root of x plus 1, squared, a minus sign. Then whatever that number is, it's a 2, I'm going to square that. On the bottom, I don't want to distribute. I just want to write it down exactly the same. Simplify the top, and then press on pause. Square, and the square root will cross off, and then I just need to write minus 4. Go ahead and simplify this top, and then press unpause. So we're finding the limit. That means we need to wait till we can plug in this number 3 till we're out of indeterminate form, which is 0 over 0. And then lo and behold, just what we expect to happen, these guys cross off. That allows me to rewrite this expression with a 1 on top, which means we're out of indeterminate form. So go ahead and plug in 3 and evaluate the limit. So by the way, we got a 4. To find the limit of infinity, remember we're crossing off everything that's small. That becomes insignificant. So we keep the largest on top and the largest on bottom. That means that this 2 can go away, this 3 can go away, this 1 can go away. And you're going to be left with this kind of awkward expression of square root of x over x. Which one's bigger? That's right, the one on the bottom. Since the one on the bottom is bigger, that means this limit converges. It converges to a number. That's right, it converges to 0. Which means that our horizontal asymptote will be y equal to 0. Now to do the rest of the stuff, the vertical asymptote, the removal discontinuity, we look back at our factored form, and we did cross something off. We crossed it off, we removed it, that means it's a removal discontinuity. So we're going to set that equal to 0, the x minus 3 equal to 0. We get x equal to 3 as a removal discontinuity. I'm going to have to do a little work with this expression. I'm going to set that last thing equal to 0, solve for it, and that'll be my vertical asymptote. Let's go ahead and solve for that. Here would be when you squared it, you got to remember that anytime you do that, it could be plus or minus that number. So I have x plus 1 is plus or minus 4. X is a negative 1 plus or minus 4. That gives me x is either a negative 3 or x is a negative 5, and both of those expressions are our vertical asymptotes.